So sketch below is the graph of h of x, and then they say we have a and b, which are the x and the y intercept of h. And then they say we should write down the equations of the asymptotes. Okay? Now, before we can write down the equations of the asymptote, we need to put this thing here in a standard form. Like, it's not in the form that we're used to. Okay? Now, the form that we're used to today, it says which y is going to be equal to a all over x minus x plus p, okay? Plus q. So q needs to be this side. Okay? Now, if you check here, we have a value here. And then we want to make sure that this thing looks like this one here again. Now, we are not transposing. We are simply going to rearrange this thing such that it looks like that one. So if we do that, then what are we going to have? We're going to have something that looks like this. We're going to have h of x, which is going to be given as, we're going to start with the fraction again. Now, let's check the fraction. Is it positive or negative? So we're going to have minus 1 all over x minus 2. Again. And then what else do you have? You have 1 again. If you have 1 here, is it positive or negative, the 1? It's going to be positive. Then you say you have plus 1. Then now it's in this form. It's in this form that we are used to. Okay? Then they say determine the equations of the asymptote. There are two. It's a hyperbolic function. We're going to have x minus 2, which is 0. And then it says x is going to be 2. Okay? And then we also have q. What is the value of q here? And then we say which 1 is going to be equal to our 2. Then it's 1, it's 2 for this. Next, they say calculate the coordinates of A and B. Let's come and check here. We'll come and highlight A here. What is happening in A here? So we are intersecting with the y-axis again. So our graph is intersecting with the y-axis. And then here, we know something about x. What can you say about x here? It's 0. So it means we are looking for the y-intercept. So if we are looking for the y-intercept, that will be our number 2. We'll say, how do you get the y-intercept? You get the y-intercept by saying x is 0 again. So we'll say which y is going to be equaling to, we have minus 1 all over 0 minus 2 plus 1. Okay? And then you can put this in your calculator. If you put this in your calculator, you have minus 1, 0 minus 2 plus 1. And then it gives us what? 3 all over 2. And then we're going to say we have 3 all over 2. It means which we can say b. Safely so. B, x is 0 again. And then what is our y? No, it's a. Sorry. A, we have 0, and then 0 goes with what? 3 all over 2, which is 1,5. Okay. The next one we want to get p again. Come and check what is happening here, p. What will you say here, p? Is the x-intercept again. What do you know about y with the x-intercept? It's 0. So you say which you have 0, which is going to be equal to minus 1 all over x minus 2 plus 1. What is the first thing that you will do here? You are going to take this one to the other side. Again. It says which you have minus 1, which is going to be equal to minus 1 x minus 2. And next thing, so we cross multiply. It says we have minus 1, open bracket, x minus 2, which is going to be equal to minus 1. Okay, what is the next thing that you will do from here? You are going to FOIL or you are going to divide again. So let's divide by minus 1. So if you divide by minus 1, it says which x minus 2 is going to be 1 again. And what you get as your x, you take this 2 to this other side again. It says which x is going to be equal to 2. Then the coordinates of b is going to be equal to 3, which goes with 1 with 0. And then we'll give you 1, 2, 3. Now let's go to the next one. The next one, they say write down the equation of the axis of symmetry. Okay? Now, symmetry, we know which if they didn't say anything about the positive or the negative, we're going to give them both of them. Okay? Now, provided our equation is in a standard form, if it's in a standard form, then we can come and take the following here. We can say we can take this one for the positive gradient. And then if we do that, we'll say, okay, this one here is number 3. We have y, which is going to be given by x minus 2 plus 1. Okay? Now here you have like terms. These two are like terms. Okay? Minus 2 plus 1. What is minus 2 plus 1? Negative 1. Mm-hmm. So it says which x minus 1. So this is going to be x of symmetry with a positive gradient. Huh? The minus here. No, we don't take the minus. And then now the next thing that we're going to do here is to say, okay, what if it's negative? What if we want the one with the negative gradient? We come to the denominator and put the negative. Okay? If we put negative there, it says which y is going to be equal to minus open bracket x minus 2 plus 1. And then you find it says this one multiplied by this one, it gives you minus x again. This one multiplied by this one, it gives us plus 2 plus 1. And then these two are like terms again. If those two are like terms, then you're going to have minus x plus 3. Then this is going to be the axis of symmetry with a negative gradient. We're not drawing them, they didn't ask us to draw them again. So we're not going to look for the x-intercept and the y-intercept of this line. They didn't ask us to draw them. Okay, last but not least, we want to get what we call the range. Range represents the possible y values. And then domain represents the possible x values. Now, how do we get the domain and the range? Our graphs can be anything except, I'm going to give you the domain and then I'll ask you to give me the range. I'll show you an example with the domain and then I'll ask you to give me the range. So our x values here, in graph is going to be possible for all values of x, except one of them. So we can write it this way. If they ask me which one was the domain, let's say they ask me what was the domain. I'll say with the domain x is an element of all the real numbers, but x cannot be whatever the vertical line is. So come and check here what is the vertical line. The vertical line says which x is 2. So x is going to be an element of all real numbers, but x cannot be 2. X is an element of all real numbers, but x cannot be what? Be 2. So based on what I just said here, what is going to be your range here? If they ask you what your range on number 4, what should you say? I said, look at this. I get the domain. The domain, if they ask me the domain, I'm going to say x is an element of all real numbers. Okay? But x cannot be whatever the vertical line is. I get x is equal to 2. It means which x cannot be 2. When you say x is 2, it means which x cannot be 2. So we want to do that for y. Range is y. So we have the domain, which is x again. So now we want to do it for y now. What are you going to say for y? So y should be everything again. So y is going to be an element of all the real numbers. But now there's something that y cannot be. There's something that y cannot be. What is y? Y cannot be what? It cannot be the horizontal line again. So y cannot be 1. And then we have the following as an activity. So we are going to do the following as an activity. And then on your activity here, you come and put number 6. Number 6 is going to be saying write down the domain and the range of f of x.